Now the last thing that we want to take a look at is finding a line that is normal to the curve. Okay, normal just means perpendicular. It's the exact same thing. Okay, so a perpendicular slope is opposite reciprocal of the slope of the tangent line. Okay, so if we know that we found the slope of the tangent line to be 3/5, then its opposite reciprocal would be -5/3. Okay? If I found the slope of my tangent line to be -4, its opposite reciprocal would be +1/4. Okay, so just quick review on perpendicular slopes. They are opposite reciprocals. Okay, so let's use that to find a normal to a curve. Okay, so this is the same function we just looked at and found the tangent line. Okay, y equals x² + 2 at x equals -1. Okay, we found the slope of the tangent line was -2. Okay. Okay. Now, since I know that the slope of the tangent line, so I'm gonna write that. My tangent slope is equal to -2. Okay? So then my opposite reciprocal slope, right? My perpendicular slope, will be +1/2. Okay? So we already found this piece of information. Okay? Now, I know that the slope of my new line is going to be +1/2, and I want it to go through that same point. Okay, and we already found that that entire coordinate point was -1, 3. Okay, so that's all the information I have. I've got my slope is 1/2, my point is -1, 3. I'm going to plug that information into point slope. So y -3 equals 1/2 times x minus -1, so x plus 1. And again, on the AP test, perfectly acceptable to leave it like that, but let's solve for y just so that we have practice. So I get 1/2 x plus 1/2. If I add 3 over, well, 1/2 plus 3 would be 3.5, or 7/2. Okay, so this would be the equation of my normal line. Right? So thinking about what we already graphed, okay, we said that this was y equals x². And we found that our tangent line, right, did something like that. Right? Now, this normal line, y equals 1/2 x plus 7/2, will do something like this. It'll be perfectly perpendicular, okay, to the curve and to the tangent line. Okay? So now, using our limits, okay, that we've talked about, we can find instantaneous rate of change. We can find the slope at a single point, and then we can use that point to write the equations of both tangent lines and normal lines. All right? On our way to derivatives.